So we were talking about what if alpha is equal to 0 and what if alpha is equal to 1, the extreme theoretical cases, to kind of get your mind a little more around that question of being smoother or being more responsive. And I hope you work this out on your own and are just here to check your answers. But if you just stick the value of 0 for alpha in this formula, you will see that you essentially get the entire error term there to disappear. So ft equals ft minus 1, which equals ft minus 2, which equals ft minus 3. So essentially you're saying, I know what I know and I'm not going to learn from my mistakes. I am not really going to look at actual values at all. If I want to produce 100 units, I will produce 100 units, and I will always forecast the sales next week to be 100 units. Regardless of this week's sales were 50 or 500, I am not going to learn from this. So alpha of 0 makes you a completely smooth forecaster, but not a very responsive one, not a very good one at all in that sense. And on the other hand, if alpha is equal to 1, you are kind of look at that. It becomes ft minus 1 plus at minus 1 minus ft minus 1. So your forecast for this period is your actual value for the last period. And we have a name for that. The name is naive method. So whenever you have a alpha value of 1, you have essentially returned to that idea of I'm only going to look at the last actual value. I'm not going to look at data points before that, and I'm going to be completely responsive to what is going on in the market. I am hoping at least some of you have come up with another question and are wondering how on earth we apply this formula when we are simply saying our forecast for this period is a reaction to the forecast and error of the last period, and on, recursing all the way back in infinity. We have to start somewhere. There's two conventions for this that are widely used. One is simply to start out with the naive approach and set your second period forecast. Say, just like in naive method, I cannot forecast the first period. I will take the actual value I see in the first period and set it as my second value forecast and carry on from there. The second convention is to use a moving average. The example I have here for you is to start with a 4-period moving average. So I will take the average of the first 4 periods and let that be my 5th forecast, calculate my 5th error, use those to come up with my 6th forecast, and so on. I will show you the first convention in action here with hand calculations, and then I will go back to Excel and show you the second convention on an Excel spreadsheet. What you do is up to you, and if you have enough data points, the results will kind of forget about the beginning anyway, and they will converge to the same thing. So how you begin is not as important if you have a rather long time series. So right here we have only one data point, and that is A1 of a value of 4. And we would like to use exponential smoothing with a smoothing constant value of 0.1. So what we do is we start out with the naive method and we say our forecast for time period 2, F2, given that the method is ES.1, is going to be simply 4, echoing our last observation. Then we wait, we observe. We see that the observation for time period 2 is 7, which gives us an error of 3. So we take 3, we take 10% of that, 0.1 times 3, or 0.3 and add it back to our prior forecast of 4 and come up with 4.3 as our forecast for period 3. Again, we let time unroll. We see our actual value for time 3, in this case, let's assume it's 4. And that gives you this time an error of minus 0.3. So you're going to add 10% of minus 0.3. In other words, minus 0.03 is how much you're going to adjust your prior forecast, and your forecast for the 4th time period becomes 4.25. So that is hand calculations for you. On the Excel spreadsheet, let me mention 2 things. Again, although we've said this before, if you have seasonality, exponential smoothing, just like moving averages, will just jerk you around. It is not a good tool for that. Or if you have a very steep trend with time, again, exponential smoothing is not a good tool for that. So having said that, of course, I'm going to, just for demonstration purposes, show you how to do this on Excel using our paper sales, which we know has a trend, a significant trend. But let's just play around with it anyway, just like we did with moving averages. So let us, this time, I'm going to use a exponential smoothing with an alpha value of 0.2. And for just getting some experience with something new, let us assume that we're starting with a 3-period moving average. So 1, 2, 3 periods of data I'm going to use to cast my first forecast, meaning that my first forecast will happen right here in time period 4. So over here I am saying, give me the average of the first 3 time periods, and then give me the difference. We have done this before. Give me the difference between my actual observation, it says OT here, we've been using AT in this class, but my actual observation and my forecast, and that is my error. Now I can set up my 5th value, my 5th period forecast, to be equal to my 4th period forecast plus my alpha times the error from last time. So this is the 0.2 is entering the formula as a constant because it is a alpha parameter of 0.2, and you could set this up and then copy it over and simply change the value of a parameter and try it out with alpha of 0.25, alpha of 0.15, and see which one works better. Of course, to get there, you have to make sure you are also computing your errors. You are computing your error squares, just as we always do. You are computing your error absolute values, and just, sorry, I can't talk and do Excel at the same time. And just carry all of this down, as we always do, and then calculate your aggregates on the basis of these. Now, the important thing is to make sure that you are counting, either manually or on Excel, you are counting the number of errors that you have accurately. In this case, you are going to have 3 fewer forecasts than you have data points. So the count for MAD, for instance, that you'd be using would be 120 minus 3, and then for MSE it would be that value minus 1. So 117 would be the number of errors you are looking at to be computing MAD. 116 would be the value, the count value you would be using in your MSE calculations. So be careful with that. If you had started with a naive method and over here the second one was the first forecast you could make, then your counts would adjust accordingly.